Alright, so this starts our physics review, and we're going to start with Newton's first law of motion, and this law states that objects at rest will stay at rest, and objects in motion will stay in motion unless an unbalanced force acts on them. So it's really the clue here, and the key is that if an unbalanced force acts, something will change. The moving object will stop, or the non-moving object will begin to move. Inertia is a big part of this law because it means that objects all resist change in motion. So if something's not moving, it doesn't want to start, and if it's moving, it doesn't want to stop. So this goes really into what we know as balanced versus unbalanced forces. Remember, a force is just a push or a pull. So here we have balanced or unbalanced forces. So what you need to keep in mind, when forces are balanced, object will keep doing what it's doing. Meaning that if it's in motion, it'll stay in motion. And this is when we're looking at something that is at like constant speed. Constant speed. An example of this would be the Earth rotating on its axis or revolving around the sun. Or if it's not moving, it will not start moving. So no motion at all. Okay, so that's balanced forces. Unbalanced forces, they're going to result in a change in motion. So the motion won't stay what it's doing. Here we're going to have a change in motion. And what that means, either if the object wasn't moving, it will begin to move. So objects begin to move as unbalanced force is applied. Or could also mean that they change their motion in that maybe they start moving, like we just said, they stop moving, they slow down, or maybe they speed up. And those are examples of an unbalanced force. Now, when we look at calculating net forces, look back at this example here. Here we have a boat going one direction, and it gives us the speed of the boat. It's going 3 meters per second north, right? And the current is headed south, so the current is acting against it. Also notice the difference in the arrows. The arrows differences signify that there are different forces acting here. So it's going against the boat's motion with 1 meters per second. So if you wanted to look at the net force on the boat, you have to subtract opposing forces. So if you have this 1 meter going this way, it's 3 meters going this way, you're going to take the larger force, the 3, minus the 1. So we have 2 is our net force is 2 meters per second, and that's our net force acting. Right? Because that's the motion. Net force 2 meters per second forward. You could also say north, but then you have a speed and a direction. That would be its velocity. All right, so that's all on calculating net force in Newton's first law.